Welcome and hello. This is a video exercise in HEC ResSim. And in this exercise, we're going to be demonstrating the reservoir decision schedule feature and the projected elevation feature in HEC ResSim. So as is the case with every exercise, we're going to start from scratch, build a network, an alternative, run a simulation, and then focus on the actual topic of the exercise, which are these two reservoir release features: the reservoir decision schedule and projected elevation. Let's go. All right, I have ResSim up on the screen. Make sure you select watershed setup for your module and then go File, New Watershed. Give that watershed a name and then select the location that you want that watershed directory to be saved to. Okay, then go ahead and click Open and then select your units and the time zone and then click Apply and OK. Okay, Okay, our watershed has been created. Let me zoom in here and sketch out a simple stream alignment by clicking the stream alignment tool, hold down Control, single left click, continue holding down Control as you sketch out a stream alignment, and then let go of Control just before your last click and give that stream a name. I'll just call it Stream 1. When you're sketching the stream, make sure to go upstream to downstream. I'm going to click the computation tool here, and then hold down Control, single left click on the stream alignment, and then I'll call that CP1. Next, I'm going to select the reservoir tool, hold down Control, single left click on the upstream end of the reservoir pool, let go of Control, single left click, give the reservoir name. All right, I'm going to add one more computation point at the downstream end, just like I did before. We'll call it CP4. Next, I'm going to go Watershed, Configuration Editor, Configuration, New. I'll call this config 1, and we'll use a time step of 1 hour. This is not used by ResSim, but may be used for other programs. Apply, OK, and watershed, save configuration, file, save watershed. All right, let's go ahead and change the module now to reservoir network. We need to create a network first based on that configuration so we can see our junctions and the reservoir that we added in. So network, new. Go ahead and select the configuration and then give the network a name, new. All right, next I'm going to click my reach tool here in the left tools menu, hold down Control on the upstream junction, single left click, let go of Control, and then single left click on the next downstream junction. You can give that reach a name, or you can just leave the name as suggested, like I'll do, and then click OK, and then repeat for the downstream reach. All right, I'm going to go ahead and network, save. Next, I want to assign an inflow to this upstream junction, so it'll flow down into the reservoir, and then the reservoir will release the water downstream from there. So with the junction tool selected, I can just right click on that junction, edit junction properties, or what I can do is go edit and then junctions, and then up comes the junction editor dialog box. I would select the junction I want, CP1 in this case, and then go to work. What I want to do here is select the local inflow tab, and that's to assign local inflow. So I'm just going to be generic and call the inflow at CP1. Multiply factor is just 1, so there's no multiplier effectively, and then click apply and OK. Now let's go ahead and actually create the time series that we will assign to this junction for the inflow. Because right now we just said that there is inflow. That's why there's a little blue circle around this junction, as opposed to the other junctions that are red and don't have that circle. All right, so let's go ahead and start by going Tools, HEC DSS View. And then I'm going to go File, New. We need to create a DSS file. So I'm just going to call it Data, and it's going to save inside of my watershed directory with all the other directories and files inside that directory. So I'm just going to call it Data. It'll create a data.dss file, which is a database of sorts. And here it is, data.dss. We have our parts along the top. I'm going to go data entry, manual time series, and then start filling in the parts. I'll say project, location, flow, 1 hour is the time step, and then I'm going to say 500 arrow 5,000 as my part F, which is kind of a custom part, because what I'm going to do for my flow rates is start at 500 and then ramp up to 5,000, and then that'll be it. Let's use the month of July. I'm going to say 1 July 2024, the first hour, and then the units will be in CFS. The type will be instantaneous value. Next, I can type in or paste in my actual values here. I was just over in Excel and I copied the values onto my clipboard in a column fashion. So I'm going to put my cursor here on the first record and then click, I think I can right click paste. Yeah, I can right click paste, or I believe this paste button works. Yep, cool. So I have values that ramp up to 5,000. That's for 31 days on an hourly time step. So I'm going to click save. I don't need to return to the edit screen, so let's click no. And then I'm going to select this record and then click the graph button up here. And it shows you what I was talking about. This is going to be our inflow to CP1, that upstream junction in that very simple reservoir network. All right, so let's go ahead and just close this for now. We will reassign that a little bit later when we create the alternative. Next, I'm in the reservoir network still, so I'm back to where I was, and then I'm going to click on the reservoir tool, right click, edit reservoir properties. All right, so let's go ahead and create our reservoir. First things first, I like to call the dam just dam. Perfect. Then over in the pool, I click pool. Then we need to set the elevation, storage, and area for the reservoir. Okay, I was just over in Excel again, and I copied that data onto my clipboard. So now I'm just going to Control V to paste, or right click, paste, and then here's that data. It ranges from 1350 elevation all the way up to 1500 with increasing storage and increasing areas. So I'm going to click apply, and then the plots populate over here on the right. Next, I'm going to click on dam. The top elevation was 1500. I'll just make up a top length of 350. That's not really used for this exercise, but oh well. Next in the dam, I'm going to right click and add a controlled outlet. Now this will allow me to specify the number of gates. I'll say there's 3 gates, and then I need to paste in or type in elevation versus max capacity of the outlet for 1 gate. Okay, I've selected that first row here and then paste. So here are my max capacity release through 1 outlet, or 1 gate of the outlet, and it's multiplied by 3. So that looks fine. I'll click apply and then head over to the operations tab. We were just on this physical tab here, and then here's the operations tab. First step here is operations new. We want to create an operation set. I'll call it operation set 1. And then what I want to do is just use the default zone names, and I'll just type in a constant value for the top of the zone elevation. I'm going to keep this pretty simple as well. So 1500 for flood control, go 1480 for conservation zone, and then the top of the inactive zone will be 1400. Click apply, and then I can double click on this plot just to see it a little bit better and make sure I got what I want. Okay, that's great. I am not going to use any rules for this entire exercise, actually. Not necessary. I'm just going to let ResSim release what it needs to maintain that guide curve elevation of 1480. But what we will be doing is coming back and using these decision schedule and projected elevation tabs in just a moment. What I'd like to do is create a base alternative first and then return to create trials using some of these features that we are going to investigate. All right, so I'll go ahead and click OK. Next, I'm clicking alternative edit. I need to create an alternative here. So I'm just going to go alternative new. I'm going to call this base. So it's going to be like my base case alternative with nothing fancy. And then the time step, I'll use 1 hour. And then I'm going to leave all the other settings the same. In the operations tab, I'll select my operations set for reservoir 1. Nothing else to do here. Look back, this is where I set the initial values, or the look back period values for all the rows we see here. The first is the pool elevation. So that's 1480, the same as the guide curve elevation. And then the release is going to be 500 CFS because that is what the inflow time series starts with for about the first 5 or 6 days. All right, the last tab here that I need to make edits to when creating an alternative is the time series, and it's asking for me to reference the time series for CP1. So as you may have remembered, we created that already Select DSS path, click that button. That'll navigate to that data.dss file, and it's right here. So I'll click open. Here's my record. And then with this selected and that record for CP1 selected in the alternative, I click set path name. And that's all I have to do. The reference has been made, and I will save my alternative and close. And then save the network, and just to be safe, save the watershed. All right, let's go ahead and switch over to the simulation module. And then we want to create a simulation and bring up the alternative so we can see it on the screen. So first is, I'll just call it Sim 1. This is going to be for the month of July 2024, which is the same time period as that inflow hydrograph we assigned to CP1, 01 July 2024. The simulation, we will begin at noon, and then the look back period will begin on the first hour of the month. And then the end date will be the last hour of the month. So that'll be the 31st at 2400. Next, I'm going to click this checkbox next to base. This is my alternative, and then click OK. All right, so the network popped into the view here. That's good. We have the simulation tree over to the right with base alternative selected. So I will click compute. That runs the simulation. And let's go ahead and take a look at the values of the reservoir here. What we see is pretty boring and expected. We have the inflow on the bottom plot, and then the outflow is exactly the same thing. In the top plot, we see our water surface elevation maintains its guide curve elevation of 1480. All right, so what I want to do now is return to the simulation module here. From my base alternative, I want to create a few trials, and I want those trials to utilize and kind of experiment with the different reservoir decision schedules. So I'm going to right click and new trial. I'm going to name this new trial 4-hour interval and click OK. And then right click, edit run, then select reservoirs. Now I'm in the reservoirs physical tab. So I want to click operations tab and then go up to operations use decision interval. All right, so the every time step is the default setting. That's once every hour for this simulation because it's an hourly time step. But what I want to do is change it to regular interval, and then I'm going to use not 1 hour, but every 4 hours. So this means that the releases can only change once every 4 hours. I'll just stick with the start time or the start hour of 0, and then the day of week and day of month are disabled because I selected 4 hours. Okay, let's go ahead and run the simulation again and see what it looks like using this trial of 4 hours instead of the default, which is 1. Okay, and compute and close. So I'm going to go ahead and right click on the reservoir plot and then zoom in. Okay, it looks pretty much the same. At the top, we have the guide curve elevation and the releases. The releases looks a little bit more jagged because it's only, 6 times per day instead of 24. So if I zoom in, we should see a little bit of jaggedness to the operation here. Again, green is the hourly, and then red is the release, which is once every 4 hours. But for the most part, it's still maintaining the guide curve elevation very closely. I'm zooming in, and you can, it's, yeah, basically right on. Okay, let's go ahead and do 2 more trials. Let's do an 8-hour trial and then a 12-hour trial. So that means that the releases can only change once every 8 hours and then once every 12 hours. And then we'll look at the results. So I'm going to go new trial. I'm going to base it off the first trial. That way I don't have to make all the same changes. This is going to be called 8-hour interval. And then OK. I'm going to right click, edit this trial run, reservoirs, and then operations tab. I'm going to go down to the decision schedule sub tab. And then instead of 4 hours, I'm going to change it to 8 hours. Oh, sorry, that was 6. There's 8. And then apply. OK. OK. Compute and close. Now I want to create a 12-hour. So new trial, just like before, except I'm going to call this one 12-hour interval. OK. Right click, edit run. So I'm editing this trial for 12 hours. click on Reservoirs, and then again, Operations tab, Decision Schedule, and we'll change the 8 to a 12. Apply and OK. OK, we'll compute the 12-hour now. Now with all these selected, I'm going to go ahead and right-click on the reservoir, plot. Then let's see what we got here. The water surface elevation is still 1480 the entire time. Let's go ahead and zoom in on the flow though. Okay, I've zoomed way in on July 5th through 8th. On the top, we have the water surface elevation, and then green is what I have highlighted. That's the very first alternative with the 1-hour time step, and then 1-hour decision as well. And then as we see green on the bottom, just as we remember it. And then let's just skip all the way up to the 8-hour. Blue would be 8-hour on top, and then here it is on the bottom for the flows. We notice that 3 times a day, the release increases as the inflow increases to maintain that guide curve elevation. This is not as dramatic as it looks, because if you take a look at the elevation scale on the left here, I zoomed way in. This is just hundredths of a foot. So based on the inflow and the geometry of the reservoir and the schedule, 8 hours is definitely enough, and even 12 hours. Let me go ahead and highlight that. So that's the yellow on the bottom. 12 hours, of course, would be twice a day. And then here it is on the top. So it's only dipping down to 0.015 or 0.02 feet off of the guide curve elevation. So for the most part, negligible. And as you can see, it's also adjusting its release every 12 hours or twice a day. Let me zoom in on just one day here. Okay, I've zoomed in on just one day. This is July 8th of 2024. And we have midnight, 6 a.m., noon, 6 p.m., and then midnight again. And it's adjusting at midnight, at noon, and then at the next midnight, it's adjusting up. And what's interesting to notice for me is that it's actually releasing more water than the inflow, which would be the green line here. Here is the green line, and then here is the actual release. So it's anticipating increasing flows, and it's getting ahead of that by releasing a little bit more, and it knows that it's not going to have the chance to release or change the release in water again for another 12 hours. And at that point, the water surface elevation is back up to the guide curve elevation, and then it again overestimates its release because it knows in advance that the water is going to be increasing. So this was a little bit of a softball inflow, very obvious and easy to manage, I should say. And that's just the nature of these deterministic models. But still very insightful and good to have a feature like this, because in reality, you may not have everybody on staff available to change the release from a reservoir at 3 a.m. on a Sunday morning. It would make more sense to do it on a periodic schedule like 6 p.m. and 6 a.m. every day. I'd like to do one more trial demonstrating the reservoir decision schedule. So I'm going to go ahead and create a trial based on an existing trial. That's fine. I'm going to name this trial 6, 12, 18, M through F, 3 times a day, Monday through Friday. And then I'll click OK. Now I'm going to go ahead and edit run to make edits, reservoirs. And I like to kind of pull this off to the side so we can still see our network. Over to the left, Operations tab, and then Decision Schedule sub-tab. Now, instead of our regular interval, I'm going to click on Weekly Schedule. So this is the hour of the day or even minute of the day that the reservoir is allowed to make updates and changes to its release. So if I just said, say, noon, that would be noon, 12 noon. It's looking for numbers between 0000 up to 23:59, which is 11:59 p.m. But if I went ahead and typed this in right here, this would be once per day at noon is the only time that the reservoir would be allowed to make changes to its release. What I want to do in this particular exercise is change it so it's 6 o'clock and then noon and then 6 p.m., which would be 1800 hours. And I want to do this for Monday through Friday. And then there's the noons. I'm just copying this by hand, Control C, Control V, Control V, Control V, Control V. So those are my values. And then I'm going to delete weekends and just say like, hey, there's no operation changing during the weekends. So we got one more, missing 6. Okay, I think we're good there. And if I click apply, I've got this warning message when preparing this lesson, and it turns out that I actually do have to have at least one value for Sunday and Saturday. I don't know if there's a way around this, but I'm just going to go ahead and play along, and I'm just going to say noon, noon, and noon for Saturday and for Sunday, and then click apply and see if that works. And then okay. Okay, so let's go ahead and run that last trial, close. Now I'm going to unselect these other trials and look at just the results for this trial 4 here. So I'll go right click and then plot. Let me zoom in. Okay, I've zoomed in on the plot here, and in the bottom we see the releases. They are changing at 6 a.m., that's noon, 6 p.m., and then not till the next morning on 6 a.m., noon, 6 p.m. And so the 12th of July is actually a Friday in 2024. And then the next day is the Saturday and Sunday. So what we're seeing here is a single change at noon and then what looks like another change at noon on Sunday. And then we could just scroll over and then scroll up and then see that, yeah, after Saturday and Sunday, we resumed the normal 3 changes per day on Monday the 15th, Tuesday the 16th, and so on. As you can tell, the guide curve elevation is again very stable at 1480. I could zoom in a number of times. So that's zooming in once. Just keep an eye on the scale over here. So I've zoomed way in. Again, we're just off by like 0.08 feet, which is 1 inch over the course of a huge reservoir. It's almost negligible. I don't want to say negligible, but that's really up to the decision makers to decide. Here on the weekend, it gets a little bit lower than on the weekdays just because of the interval of when the flows are allowed to change. So that's another way for us to schedule the releases in the reservoirs in such a way that it's a little bit more realistic because again, you might not have someone there at 3 a.m. on Sunday morning unless it's an emergency situation, in which case you may have all hands on deck. Okay, the last thing I want to do for this exercise is I will go ahead and actually stick with this alternative. So let me just make sure I'm doing this right. I'll edit and then reservoirs. Next, instead of decision schedule, we'll leave this as it is. And I want to go ahead and click on operations menu, compute projected elevation. So what I'm doing here is I'm asking ResSim to give me the projected elevation at a certain number of hours past the current time step. With that last simulation, we were changing the flow every 6 hours on weekdays and then once a day on weekend, except for, I guess, midnight. So I'm just going to go ahead and click type 6 in right here. And we'll go ahead and also use the projected reservoir elevation to determine the operation zone. So what I'm going to do is click apply, run the simulation, and we'll check out what this means. Apply, okay, compute, close. Now, if you look at the plot, it won't look any different. But what I did do is I went up to Tools, HEC DSS View. Now we have all of our data from the simulation and all the trials as well. I want to focus in here on the 4th trial data just to start the filtering process. So I'll select the 4th trial in my filter. I'm looking for the projected, here it is, elevation projected off of reservoir. So this is one of the time series that I want to look at. And the other one is the actual elevation of the reservoir pool. So let me find that record. It will still be base 4, so we'll leave that filter in place. And here's the pool, and then here's the elevation. So I'm going to hold down control and then single left click on this record. So that actually selects both records at the same time, just the same way a normal list box works. So that's selected, that's selected. I'm going to right click and then duplicate. And all I want to do is create a easily to filter value on this part F. So I'll just say something like custom 1 and then okay. It's creating a duplicate record, 2 records actually. That's good. And then over in part F, I'm going to select the, hold on, let me unselect them all. So I think that refreshes the list of options. And then I should see custom 1. There it is. And here are the 2 time series that I'm going to open up together. So I select them all at the same time and then click this plot button. And let me just go full screen with it. I'm going to zoom in here on our data. And what we see is the water surface elevation, again, is either 1480 or it goes down about 1 inch. No big deal there. That is the reservoir pool data, but what's harder to see is this first series of data, which are this little data points. And I'm going to go up to view, no, edit, plot properties. And then, yeah, so this is first series is the selected series. I'm going to select draw points and then apply. And actually I can make them a little bit bigger and then apply. Okay. So now I see those points on the graph and I'm seeing, yeah, every 6 hours, I'm seeing a projected elevation. They're pretty close. I mean, very close if you consider the scale here is just thousandths of a foot. Using these advanced features in the reservoir editor, the reservoir decision scheduling, and the projected elevation allows us as water modelers to better understand the system and plan for these scenarios that may not be every day, but would definitely be used in certain situations using HEC ResSim.